Okay, so I'm going to real quick go over how to find the line of regression and how to do our interpretations that we've been doing in class. So the first thing you want to do is whenever I ask you to find a line of regression, remember that is going to be the equation of the line that goes through the middle of the data points. So the first thing we want to do is we want to take all of these data points and we want to put them into Desmos. Okay, so the first thing I'm going to do is I'm going to go to Desmos now. To put the table in, I'm going to click the plus sign and I'm going to click table. Okay, now notice that we have X1 at the top and Y1 at the top. That's going to be really important when it comes to our equation in the next step. So the next thing I want to do is I want to enter all of this data in. So I'm going to go through 370. So if you want to do this 1216 while I pause the video and go through and put all of these data points. Remember, you learn best when you do it. So you guys go through and put all of these data points in your calculator. So remember also that when we're looking at this set of data, we're talking about the distance in miles and the airfare. So we're talking about how much it's going to cost to fly a certain number of miles from Baltimore. Okay, so when we go to find our line of regression now, this little magnifying glass that you see on the left-hand side at the bottom is going to take your Desmos graph and it's going to make it so that you can see all of your points. Because if you look right now, we can only see from -10 to 10. So if I click that, it makes it so that it auto zooms my graph so that I can see all of my points. So we can see from this that our graph is probably increasing for the most part. And, you know, I think they might end up being pretty close to the line of best fit. So now what we want to do is we want to go down to line 2 and we want to find the regression line. So the way that you're going to do that is you're going to type Y1. Okay. We got to find our little squiggly sign, which in Desmos, you can do it on your keyboard. In the Desmos app, though, you might have to go to the keyboard. It's going to be right down here. Y1, little squiggle. And then we want to do MX plus B. So M, but when I type in my X, I need to do X1 because that's what my table says. Plus B. Okay? So once you type in that formula, if you typed it in correct, it should automatically come up with your line of best fit. Okay? So when I'm looking for my equation, I'm going to look for the M and the B that's at the very bottom. Okay, the M is going to be my slope and the B is going to be my y-intercept. Okay, so we're going to say that our equation, I'm going to round to 2 decimal places. So if I have 0.096, I'm going to cut it off at 0.09. But since there's a 6 after that, I'm going to bump that 9 up to a 10. So it's going to be 0.10. So let's write that. It's going to be y equals 0.10x, and then my y-intercept was 100.63, but it's 0.636, so I'm going to make it 100.64. Okay, and we know that our x is the distance and our y is the airfare. So x equals distance in miles, and y equals airfare, which is in dollars. So always try and remember to identify your variables. All right, the correlation coefficient is going to be the R value. So it's 0.8796. So correlation coefficient is, and we always use R to represent that. R equals 0.8796, which if I want to cut this off at 2, I'm going to make it 0.88. Okay, which 88%, that's pretty strong. So we're going to say that this is a strong correlation. It's also positive. So positive means that your line, or actually let's not say line, let's say that the data is increasing. Data is increasing. And because it's strong, we're going to say that the points are close to my regression line. Okay. So that's the correlation coefficient. You always want to interpret it, whether it's strong or weak, whether it's increasing or decreasing, and whether your points are going to be close or far from your line of best fit. Okay? So now we want to interpret the slope. So remember, slope tells you how something's changing. So in this problem, let's change our color so it doesn't run. My slope is going to be the m value. So my m here is 0.10. Okay, and slope is always going to be telling you what the y value does. So we're going to say the airfare, and since it's positive, it's going to be increasing. The airfare increases. Now remember, airfare is in money, so we're going to say that it's increasing by about 10 cents, right, per mile that you fly. Okay. Now your slope interpretation doesn't have to be word for word like mine, but it should be saying in some sense that the price is going up 10 cents for every mile that you fly. Okay, so basically every mile costs 10 cents. Okay. All right, now we have to interpret the y-intercept. So remember, the y-intercept is this number here, so 100.64. Okay, so the y-intercept here is going to tell me, well, y-intercept is always when x is 0. We know that. So we're going to say when the distance is 0. So in order to fly, if you flew 0 miles, the price would be 100.64, right? Which if we look at our Desmos graph, you'll see right here, right, the y-intercept there. Does it really make sense? No, because you're not really gonna fly 0 miles, but it's almost like that's maybe like your flat fee or your one-time fee that, you know, it always starts somewhere around 100. Okay, so that's how you interpret the slope and how you interpret the y-intercept. Now we're gonna come down here. I'm gonna copy this just so I still have it when I go to the next slide. Okay, we know that x was distance in miles, and I know that y is airfare in dollars. Okay, so now we're going to use our line of regression to make some predictions. So if I want to make a prediction, what is the cost of a trip that's 790 miles, right? So I got to go up to my variables. I know that miles are going to be the x value, right? So miles are what I plug in. Airfare is what I get out. So I'm going to plug 790 miles into x right there. So I'm going to say y equals 0.10 times 790 plus 100.64. Okay. So now you can go to your calculator. Okay. I would use either your graphing calculator if you have one, or the the Calculate 84 app on your phone. So if you don't have that, it's called Calculate 84. It's a really good calculator to use on your phone, or you can use the Desmos calculator. That will do it also. Desmos scientific calculator. 0.10 times 790 plus, 0.10 times 790 plus 100.64 gives me 179.64. Okay, now remember y values here. We know y is airfare. So airfare is going to be dollars. So we're going to say to travel 790 miles, it is predicted, because we don't know if it's for sure, it's predicted to cost $179.64. So that's our answer. Okay, so we used our equation to make that prediction. Now, when you actually go to fly that amount, is it going to be that exact cost? No, but we're going to predict that it's going to be close to that. Okay. All right, now, how many miles do you travel for a trip that's $109? So we know $109 is the airfare, right? And I know that airfare is going to be plugged into the y value. So I have to plug that in over here. And I don't know what x is here. Okay, so now I have to go through and I gotta solve a two-step equation. So I know I put my line down my equal sign. I know I'm trying to get x by itself. So the first thing I gotta do is I gotta subtract. Subtract 100.64. Okay, so that's gonna cancel, and when I do 109 minus 100.64, I come out with 8.36. And then I still have 0.10x, okay? Now that 0.10 is being multiplied by x, so I'm going to divide by 0.10, and I come out with 83.6. So if you flew on a trip that was $109, remember x's distance, so this is gonna be miles, right? You will have flown 83.6 miles. So if your trip, I'm gonna write this over here. If your trip costs $109, oops, it is predicted that you flew 83.6 miles. Okay, so that is your interpretation there. Okay? So make sure every time you interpret, or every time you make a prediction, that you go through and you kind of interpret what it means. Okay, so that kind of covers everything that you need to know about linear regression. Make sure that you know how to find the line of regression using Desmos. Make sure you know what the correlation coefficient is and how to tell if it's strong or if it's weak or if it's increasing or if it's decreasing. Make sure that you can interpret the slope and interpret the y-intercept. Remember, slope is always how it's changing, so is it increasing or decreasing? And your y-intercept is always your starting point. So where does it start at when x is 0? Okay, and then you have to know how to make a prediction. So plug in for x and solve, and also you need to know how to plug in for y and solve.